Hi friends, in this video we are going to study total derivative of z with respect to x, y. So here before that first I want to discuss what is meant by composite function in single variable and composite function in two variable. Let's say here I will discuss one by one. So here for example let's say z equal to f of x comma y. So here z equal to f of x comma y is a function of two variable x and y, and here is a function in two variable, let's say two variable x comma y, and x comma y is a function of, let's say, function of t, that is x equal to, let's say, phi 1 of t, and y equal to, let's say, phi 2 of t, that is, let's say, x is a function of t, one function, and y is another function of t, let's say, phi 2 of t. Then z is the function of t. So here just observe one thing, let's say z is the function of two variable x and y, and x is the function of t, and y is the function of t. So here z is the depend on two independent variable x and y, and x is the function of again t. So x depends on again single independent variable t. So here with respect to this function z equal to f of x comma y. So here z is my dependent variable which depend on these two independent variable x comma y which work as an input for this function f. So this z depend on these two independent variable x and y, and this again x is again a function of single variable t, that is x is depend on this single with respect to this function x is here with respect to this x is my independent variable corresponding to this. Now with respect to this here this is my dependent variable and this is my independent variable. So here let's say this is my here z is the function of two variable x and y. So corresponding to this function, so x and y work as an independent variable, and z is the dependent variable which depends on these two independent variable x and y. But now just observe one thing, x is the function of again t and y is the function of again t. So here now come to here, x is again function of t. So for this function my x equal to phi 1 of t. So x is output and t is input corresponding to this function phi 1. So x corresponding to this phi 1, x is my output, that is this output, that is dependent variable depends on the independent variable t with respect to function phi, and this t is the independent variable corresponding to this. Now in the same way here y is here corresponding to this, y is the independent variable and z is the dependent variable, and now corresponding to this here again y equal to phi 2 of t. So corresponding to this function phi 2 of t, y2 is my dependent variable which depend on t. Therefore z is the function of t, and z is the function of t via x, and z is the function of t via y. Therefore this is called, z is the composite function of single variable t via x and y. So here this is the z is a function of two variable x and y, and x and y is a function of t, that is therefore it is called therefore z here there so here so sorry here z is the function of two variable x and y is the function of single variable t, then z is called composite function of single variable t, let's say t. This is the composite function of the single variable t. Now sometimes let's say here I will define another function. Let's say z is the function of, let's say, f of u comma v. Now just observe this function here, z is my output, f is my function, u comma v is work as an input for this function. So this is the dependent variable which depend on these two independent variable u comma v. Again I will here with u equal to, let's say, phi 1 of x comma y, and let's say v equal to phi 2 of x comma y. Now just observe one thing. So here z is the function of u comma v, and u comma v is again a function of x comma y. So here this is again a function of x comma y. If z is the function of u comma v and u comma v is again a function of x comma y, then z is the function of x comma y. So here corresponding to, just follow this route. So here z is the function of u and u is the function of x comma y. Then why are you, z is the function of x and y. Then in the same way, if z is the function of v and v is the function of x comma y, then z is the function of x and y through v. Therefore this z here, this z is the composite function of single variable t through x and y, and this z is the composite function of two variable x and y through u and through v. So this is the composite variable function. Z is the composite function of single variable t, and this z is the composite function of two variable x and y. So here this is the definition of composite function. Here z equal to f of u comma v, and u equal to phi of x comma y, and v equal to phi 2 of x comma y. Then z is called composite function of let's say two variable x comma y. So here this is the definition of composite function of two variable and composite function of single variable. So here just observe one thing. In my last video I said, whenever your function depends on single variable, at that time you can take here, just observe here, z depends on two independent variable x and y. At that time take partial derivative of z with respect to x and partial derivative of z with respect to y. But corresponding to this function, x is depend on single. So here x is depend on single independent variable t. At that time you have to take the ordinary derivative x with respect to t and y with respect to t. Now here this is corresponding to this. Now come to here. Here z depends on two independent variable u and v corresponding to this first function, and corresponding to second function u is again dependent on two independent variable x and y corresponding to this function, let's say phi 1, whatever may be. Therefore here in both the case partial derivative of z with respect to u, and again here also you have to take partial derivative of u with respect to x and u with respect to y, because z depends on two independent variable, again u depends on two more than one independent variable, that is x and y. So here in this case, so here first I will write this. So first I will write this. So now here z depends on u comma v. Therefore do z depends on u comma v and u comma v depends on x comma y. Therefore do z by do x equal to, here I want to reach 2x through u and v. Do z by do x equal to, here x, here do z by do x I want to reach x through u comma v, through u and v. So because z is the function of u comma v, so here z is the function of u comma v and u is the function of phi 1 of x comma y, and v again function of, let's say, phi 2 of x comma y. Now here I want to reach x, I want to reach from z to x through u comma, through u and v. So do z by do x I want to reach to from z to x through u and v. Do z by do x equal to do, here z depends on u, so do z by do u, because z is the function of u comma v and u comma v is the function of x comma y. Do z by do u into do u by do x plus do z by, here this is one root through u, and second is do z by do v into do v by do x. So here this is the from z to x through u and v root, and here and do z by do y through u comma v. So here from here to here and here to here, from here to here and here to here. So here and directly here. So this is, so dou z by dou u into dou u by dou y plus dou z by dou v into dou v by dou y. So this is called the chain rule of partial derivative in two variables. So this is called the chain rule of the partial derivative. So this is called here chain rule of partial derivative. When your function, when z is the composite function of two variable x and y. In the starting here, for corresponding to this, z is the function of u and u is the function of x. Here z is the function of v and then x. So here z is the function of u comma v is the function of x comma y. That's why z is the composite function of the two independent variable x and y. So corresponding to this direct function. Now I want to define the total derivative. So here this is the definition of composite function of the single variable t, and this is the definition of composite function of two variable x comma y. Now here I want to define the, so this is my chain rule, dou z by dou x through u and dou z by dou y through u and v, dou z by dou x through u and v. Now here I want to define the total derivative. So just now I said, when your function depends on the more than two variable, at that time let's say here, let's say z equal to f of x comma y. So here z is my output and x comma y is my input. So here this z output depends on these two independent variable, and here I am defining, let's say x equal to phi1 of t and let's say y equal to phi2 of t. Here z depends on two independent variable x comma y corresponding to this function, and here let's say this is my phi1, let's say this is my here phi2. So here let's say this is my f. So here corresponding to this f and this is, so here z equal to f of x comma y. So z is output and x comma y is input. So this output depends on these two independent variable x comma y, but this output corresponding to this function depends on this single independent variable. Therefore the total derivative of z of with respect to t, so here z depends on these two independent, so z is the function of x comma y and x comma y is the function of t, then z is the function of t. So here z is the function of t. In the same way, z is the function of x comma y is the function of t, therefore z is the function of t through this. So here z is the function of x comma y and x comma y is the function of t, then z is the function of single variable t. Here corresponding to this, z is the function of two variable x comma y and x comma y is the function of t, therefore through this z is the function of t via x and z is the function of single variable t via y. Therefore now I want to find the total derivative of z with respect to t via x and y. Therefore dz, that is total derivative of z with respect to single variable t, is equal to, here z is the function of starting x comma y. So first take partial derivative of z with respect to x, but x is the variable, x is the function of single variable t. So here into dx by dt plus z is the function of again y. So here y, and here this is dou z by dou y into again y is the function of t. So therefore dy by dt. So here total change in z because of t depends on total change of z through x, and here this is dx by dt. So this is my here this is change in x and this is change in y. So let's say this is the performance of student. So let's say performance of the student depends on let's say study hour and sleeping hours. So here performance depend on, let's say performance, here performance equal to, let's say u equal to performance of your student, u equal to depends on the function of two independent variable. Let's say study hour. So here study hour into sleeping hour. Let's say sleeping hours. So here let's say this is, and study hour and sleeping hour is the function of t. This is hours is the function of t. So here performance of your student depends on study hour into dx by dt. So dx by dt plus do u, let's say do u by do y, let's say this is do dv, let's say this is my x, and y, let's say this is my u. So here do u, and so here this is the function of t and this is again function of d, therefore dt equal to do u by do x into dx by dt plus do u by do y into dy by dt. So here performance of my student depends on this combination of this study hours into sleeping hours. So here study hour depends on time and again sleeping hour depends on time. So here, so u is the function of, let's say u is the performance is the function of study hours. Study hour again a function of t. Performance is the function of sleeping hour. Sleeping hour again is the function of time, that is t. So here the total performance of my student depends on this study hour as well as sleeping hour, the combination of these two. So that is the total derivative. Therefore the total derivative of z with respect to t equal to dou z by dou x into dx by dt plus dou z by dou y into dy by dt. In the same way, here now I will solve some example. This is my total derivative. So here this is my total derivative of z with respect to, so with respect to t. So here this is the total derivative of my z with respect to t via x and y. So here combination of both, that is my total derivative. So effect of t over z through x and through y. So here the sum of these two is my total derivative, dz by dt equal to dou z by dou x into dx by dt plus dou z by dou y into dy by dt. So here now I will solve one by one example, so you will get one idea. Now here I will solve first last example. So here if u equal to xy plus here xy plus yz plus xz, that is u is the function of x comma y comma z, and x is the function of t and y is the function of t and z is the function of t. Therefore you have to find the total derivative of, that is you have to find here, find du by dt equal to what. So here first of all write the given information. So here I will write my first here answer of my, first I will write my question number 4. So here first given thing. So here u is the function of, here u equal to, let's say f of x comma y comma z, which is equal to xy plus yz plus xz is the function of three variable x y z. So and x is the function of t, and here with x equal to 1 by t and y equal to e to the power t and z equal to e to the power minus t. So here x is the function of single variable t, y is the function of single variable t, and z is the function of single variable t. So we have to find total derivative of u with respect to t equal to, so here u is the function of u, this is dou x, and x is the function of single variable t. Again u is the function of y and y is the function of t. Again u is the function of z and z is the function of single variable t. So here why I am taking here partial derivative, because u is the function of x, y, z more than one variable. That's why here I am taking partial derivative of u with respect to x. But why I am taking ordinary derivative here? Because x is the function of single variable t. That's why here I am taking ordinary derivative. Again u is the function of more than one variable, dou u by dou y. This is ordinary because y is the function of single variable. Again dou u by dou z, u is the function of three variable partial. This is ordinary because z is the function of single variable t. t. Therefore, first now I want to find dou u by dou x, dou u by dou y, and dou u by dou z, and dx by dt, dy by dt, and dz by dt, and put this all value in this equation. So after that, whatever the answer you will get, that is your final answer. Now here, now I will find the partial part first. So dou u by dou x. So here u equal to this partial derivative of this function u with respect to x. While taking the partial derivative of u with respect to x, treat y and z as a constant. So treat y and z as a constant. So here y is constant. So here partial derivative of xy, that is simply y. Now plus this is yz. So both are constant, so 0. This is xz. So simply z. Now partial derivative of u with respect to y. So here I want to find partial. So while taking the partial derivative of u with respect to y, at that time treat x and z as a constant. So here I want to find partial derivative with respect to y. So here this is my x plus here z. So plus z. So here y is not there. So 0. So partial derivative of u. So partial derivative of u with respect to z, which is equal to, now here z is not there. So complete term is constant 0. Z is there. That's why here this is y. Now here z is there. That's why this is plus x. Therefore partial derivative u with respect to x is this, u with respect to y is this, and u with respect to z is this. Now I want to find ordinary derivative because x is the function of t. So here first now I want to find dx by dt. So now the derivative of 1 by t is, this is minus 1 by t square. Now I want to find dy by dt. So here I want to find dy by dt, which is equal to derivative of e to the power t, simply e to the power t. Now I want to find dz by dt. So here this is dz by dt, which is equal to, here ordinary derivative. So here e to the power minus times e to the power directly minus t. So e to the power minus t into derivative of exponent, that is minus 1. So here this is. Now just multiply. Therefore here, therefore total derivative du by dt equal to dou u by dou x into dx by dt. Dou u by dou x is, this is dou u by dou x. This is y plus z into dou x into dx by dt. This is minus 1 by t square plus dou u by dou y. Dou u by dou y is, this is x plus z into dy by dt. This is e to the power t plus dou u by dou z. Dou u by dou z, that is y plus x into dz by dt. This is minus times e to the power minus t. Now just observe one thing here. Here u is the function of, u is the function, here u is the function of x, y and z, and x is the function of t, y is the function of t, and z is the function of t. So anyhow you have to write u is the function of t. So here I want to write this whole equation in terms of t, because here u is the function of single variable t, but here I want to write y, z, x, y, z in terms of t with the help of this given information. Now here just put this value here, which is equal to, here the value of y. Value of y equal to, so here is the value of y. Value of y, here just put e to the power t. The value of z, this is e to the power minus t into, so here I will take this minus sign here, this is by t square. So here I will take this minus sign here. The value of y is e power t, value of z is e power minus t, and this minus sign by t square plus, now the value of x, the value of x is here 1 by, this is t, plus the value of z, the value of z is e to the power minus t, and the multiply by e to the power t here, plus the value of y, here the value of y is e to the power t plus 1 by t and whole multiplied by, here this is minus sign, here I will write this is minus sign, this is e to the power minus t. Now here just adjust the things. So here this is minus sign. So how to adjust is the following. Now this is just take right, just multiply this minus sign, e to the power t by t square, and minus this is e to the power minus t by t square plus 1 by, so here e to the power, here this is t by t, and this is plus e to the power minus t into e to the power t minus this is e to the power t into e to the power minus t minus e to the power minus t by t. So here just adjustment, which is equal to right here e to the power t by, so t square, here just write first as it is, t square minus e to the power minus t by t square, now plus e to the power t. So here e to the power t by t minus e to the power minus t by t square, sorry t. So this is, here I am writing this. Now just observe one thing, this is e to the power minus t plus t, so this is 0 minus e to the power minus t plus t 0, which is equal to, here I will take 1 by t square common, here minus 1 by t square common, this is equal to e to the power t plus e to the power minus t plus, here I will take 1 by t and e to the power t common, here sorry I will take just only 1 by t common, so this is 1 by t, this is e to the power t minus e to the power minus t, so plus minus 1 gets cancelled, so here this is plus and this is minus gets cancelled, this is equal to, so this is your final answer. So here so minus 1 by t square into e to the power t plus, so this is your final answer. So therefore the total derivative of u with respect to t, so this is your final answer. Now I want to solve the question number 3. So z equal to this, so this is your final answer. So I hope please pause and write the answer. So now I want to find the, now I want to say the question number 3. Now, so here in the question number 3, if z is the function of two variable x comma y, here if z is the function of two variable x comma y, and x is the variable of t, single variable t, and y is the function of single variable t. So here through x, z is the function of single variable t, and through y, z is the function of single variable t. So here this z is the composite function of single variable t. So here according to definition. Now we have to find the total derivative of z with respect to t at t equal to pi by 2. So here pi by 2. So here how to find is the following. Now here I want to write the answer of this equation, question number 3. So here first write the given information. Given z equal to e to the power x y, and so here first write with x equal to t cos t and y equal to t sin t. So here, so we have to find dz by dt at t equal to pi by 2. First we have to find dz by dt, and after that just put t equal to pi by 2, you will get the answer. So here therefore find dz by dt equal to, so here z is the function of two variables x and y. So here dou z by dou x into dx by dt plus dou z by dou y into dy by dt. Now find dou z by dou x, dou z by dou y, dx by dt, and dy by dt. So first I want to find dou z by dou x. Therefore dou z by dou x, keeping y as a constant. So here if z equal to e to the power x plus y, so here derivative of x y into derivative of x y with respect to x. So this is y. So y times e to the power x y. Now find dou z by dou y. Here in the same way, this is e to the power xy into derivative of exponent, that is simply with respect to y. Treat x as a constant. So here this is x. So here x times e to the power x y. Now I want to find dx by dt. Here I want to find dx by dt and dy by dt. So here this is the product of two functions. This is my one function, this is my two function. So you have to use the formula for derivative product of two function. F d, f as it is derivative of g plus g as it is derivative of f. So here I will use this formula over here, dx by dt. So here I will consider this is my first and this is my second, f and g. So here t as it is derivative of cos is, so derivative of cos x is sin x. So here derivative of cos x is minus sin x. So here this is minus sin t, and so plus cos t as it is, cos t as it is, and derivative of g, that is so first as it is derivative of second plus second as it is derivative of first, that is 1, which is equal to, so minus times t sin t plus cos, this is t, derivative of sin cos t, yes. So this is dx by dt. Now I want to find dy by dt. So here now I want to find dy by dt, that is dy by dt, which is equal to, here again I will use the product of two, here dy by dt first and second. So here first as it is derivative of sin t is, this is cos t, and plus sin t as it is derivative of second, that is t is 1. So here which is equal to t times cos t plus this is sin t. Now therefore total derivative of z with respect to single variable t equal to, so here dou z by dou x, dou z by dou x, that is y times, so here dou z by dou x into dx by dt plus dou z by dou y into dy by dt, which is equal to dou z by dou x is here y times e to the power xy dx by dt. So dx by dt is this. So here minus t times sin t plus this is cos t plus dou z by dou y. Now where is the dou z by dou y? Dou z by dou y is x times e to the power x y, and dy by dt, dy by dt is this. So here t times cos t plus sin t. Now here completely convert this equation in terms of t. So here which is equal to, here at, so here first I will find at t equal to pi by 2. So I want to find the value of x and y at t equal to pi by 2. So here x equal to, so here x equal to pi by 2 times this is cos pi by 2, which is equal to pi by 2 times cos pi by 2 is 0, which is equal to, so 0, and y equal to pi by 2 times sin pi by 2. So here sin pi by 2. So here pi by 2 times sin pi by 2 is 1, which is equal to pi by 2. So here at t equal to pi by 2, therefore dz by dt at t equal to pi by 2. So here x is 0. So here if x is 0, so here if x is 0 and y is pi by 2, so here y is pi by 2, just y is pi by 2 and x is 0. So e to the power 0 into this is y is pi by 2, this is minus, this is pi by 2, this is sin pi by 2 plus cos pi by 2 plus here plus this term. So here 0 into e to the power 0, this is pi by 2, here this is pi by 2 cos, this is pi by 2 plus sin, this is pi by 2. Now which is equal to, this is pi by 2 e to the power 0 into anything 0, e to the power 0 is 1. So here e to the power, this is simply e to the power 0, and this is minus pi by 2, sin pi by 2 is 1, cos pi by 2 is 0. This is my first term, plus here 0 into anything, so here this is 0, which is equal to pi by 2 times, so here this is minus pi by 2, so here pi by 2 times this is minus pi by 2, which is equal to minus pi square by 4. So therefore the total derivative of z with respect to t is minus pi square by 4. Therefore total derivative of z with respect to t is equal to minus pi square by 4. This is your answer. Now I want to solve question number 2. So here in the question number 2, what they ask, just so I hope all of you please pause and write this question. So I don't have space. Now I want to write question number 3, answer of question number 2. So here 2 is over. Now, so here if z u equal to x square plus y square plus z square, that is here u is the function of three variable x, y and z, and x is the function of single variable t, y is the function of t, and z is the function of t. So here u is the function of t through z, y and x. Therefore we have to find the total derivative of u with respect to t through x, y and z. So here how to find is the following. Now tell me, here first write the given information, answer. First write the given information. If here given u equal to x square plus y square plus z square, and with here with x equal to e to the power t, y equal to e to the power t sin t, and z equal to e to the power t cos t. Now partial, so total derivative, so here total derivative of u with respect to t, that is dou u is the function of three variable, dou u by dou x, but x is the function of single variable t, plus u is the function of again y, u is the function of yes y, and this is dy by dt, again dou u by dou z, again dz by dt. So here you have to find the total derivative of u with respect to through x, through y and through z. So here because in the initial u is the function of three variable x, y, z, and then x is the function of t, y is the function of t, and z is the function of t. Therefore u is the function of t through x, y and z. So this is through x, this is through y, and this is through z. So here for that purpose first you have to find dou z by dou u by dou x, dou u by dou y, and dou u by dou z, and then dx by dt, dy by dt, and then dz by dt. So here first I will find dou u by dou x, treating y and z as a constant. So here if u is this, so dou u by dou x is, this is simply 2x, dou u by dou y, which is equal to 2y, dou u by dou z, which is equal to 2 times z. Now I want to find partial ordinary derivative of x with respect to t. So here I want to find dx by dt. So e to the power, derivative of e to the power t is e to the power t, and derivative of exponent t with respect to t is 1. So here now dy by dt. So here product of two function t sin t. So here you have to find ty by dt first as it is. So here I will consider e to the power t as it is, derivative of sin t. Derivative of sin t is here, this is cos t, plus this is sin t as it is. So here sin t as it is, and to derivative of exponent is e power t. So here first as it is, derivative of sin t is cos t, sin t as it is, derivative of e to the power t is t, and now come to here derivative now here dz by dt, which is equal to, now first as it is derivative of second. So here first as it is derivative of cos is, here this is minus sin t plus cos t, second as it is cos t into derivative of first. So here this is my, so here I will write this is equal to here cos here t e to the power t minus this is sin t e to the power t. Now here you can take e to the power t common and write, so no issue. So here which is equal to so here also you can take e to the power t common, here I will take, so e to the power t in bracket cos t plus sin t, here e to the power t in bracket cos t minus this is sin t, and this is my dx by dt. Now the total derivative, therefore total derivative of u with respect to t, which is equal to through x, through y, through z. So through x into dx by dt plus through y. So here into dy by dt plus through z into dz by dt. Now tell me, so dou u by dou x, here dou u by dou x is 2x, so which is equal to 2x into dx by dt into dx by dt. So here this is e to the power t plus this is dou u by dou y. So dou u by dou y means here 2y times, so here 2y times dy by dt. So here write this into e to the power t times, so here this is cos t plus this is sin t plus, now dou z by dou u. So here dou z by dou u, where is dou z by dou u? This is 2z times, so here dz by dt. So here this is my z, so here dz times this is my e to the power t times cos t minus sin t. So here first convert this whole equation in terms of t. So here you know x equal to e to the power t, which is equal to this is 2 times the value of x is e to the power t and this is e to the power t. So here 2 times 2 x, the value of x is 2 e to the power t and this is e power t plus this is 2 times the value of y, just put the value of y. So here this is e to the power t, this is sin t and this is one more e power t, and here cos t plus sin so t plus 2 z times the value of z is e to the power t, this is cos t and this is one more e to the power t, this is cos t minus sin this is t. Now just observe one thing, e to the power t, e to the power t, e to the power 2t, e to the power t, e to the power t, e power 2t, e power t, e power t, e power 2t. So here 2 to get common, take common, 2 times e to the power, I will write one more time 2t, I will take 2 times e to the power 2t common, 1 plus this is simply sin t in bracket, this is cos t plus sin t plus, now from here this is cos t remains here cos t, this is cos t minus sin t, now which is equal to, so here this e to the power 2 times this is common, so here 2 times e to the power 2t in bracket 1 plus, so here multiply this sign, so here this is sin t, this is cos t plus sin square t plus cos square t minus this is sin t, this is cos t. Now here this is plus sin t cos t gets cancelled with this, which is equal to 2 times e to the power 2t, here 1 plus here sin square t plus cos square t, so here this is sin square t plus cos square t, so here this is equal to 1, 2 times e to the power 2t, here 1 plus this whole thing is 1, which is equal to here 4 times e to the power 2t, that is your total derivative of u with respect to t. So here now I want to solve the first question, so I hope all of please pause and write the answer. So now I want to write the answer of question number 1. So u is the function of x comma y here, and x comma y is the function of t. Again same, you have to find the total derivative of u with respect to t. So here given answer of 1, given u equal to sine of x comma y. So this is given, and with here with x equal to e to the power t and y equal to t square. So find the total derivative of u with respect to t. So you have to find du by dt, which is equal to change through x and change through y. Here du by dou x into dx by this is dt plus dou u by dou y into dy by dt. So total change in u through t is through x and plus through y. So here first you have to find dou u by dou x, dou u by dou y, dx by dt and dy by dt. So here first I will find dou u by dou x. Now here u is the function of x comma y. So here derivative of sine is cos of x comma y into derivative of angle, derivative of x by y, that is derivative of x by y with respect to x, treating y as a constant. This is simply 1 by y here, which is equal to 1 by y times cos of x by cos of x by y. Now I want to find dou, so this is my dou u by dou x. I want to find dou u by dou y. So here derivative of sine is again cos of x by y, derivative of x by y with respect to y. So this is my minus x by y square. So this is equal to minus x by y square cos of x by y. This is my dou u by dou y. Now I want to find dx by dt and dy by dt. So here I want to find dx by dt. So here x equal to e to the power t, dx by dt is simply e to the power t, and I want to find again dy by dt, which is equal to, so here t square, derivative of t square is simply 2 times t. Therefore the total derivative, therefore du by dt, which is equal to dou u by dou x into dx by dt plus dou u by dou y into dy by dt, which is equal to, now tell me dou u by dou x, that is 1 by y times, so here 1 by y times this is cos of x by y, and dx by dt, this is simply e to the power t plus dou u by dou y. Dou u by dou y means here this is, I will write this is plus into the directly minus x by y square. So here this is cos of x by y into dy by dt, that is dy by dt is simply 2t. Now I will convert this whole in terms of t. So here this is equal to 1 by y, the value of y is t square, 1 by y square is 1 by t square. This is cos of, here cos of x is e to the power t and value of y is t square into e to the power t. So here minus the value of x e to the power t by value of y is t square, y square is t to the power 4. This is cos of e to the power t by this is t square, and this is my 2t. So just write as it is. So here this is equal to e to the power t by t square. This is cos of e to the power t by t square minus, so here anything cancel. So here 1t and this is 1t. So here minus 2 by t cube. This is e to the power t cos of e to the power t by t square. Now anything common. So here I will take this is equal to e to the power t common. So from here t square, e to the power t and t square here I will take common. So here again I will take cos of e to the power here t by t square here. Now first term remained 1 minus this is 2 by t. So I think this is your final answer. Therefore, the total derivative of u with respect to t is this. So thank you.